All right, your big quizzes are graded. Obviously, you've seen the scores are put in, but I still got some kids that haven't taken it, so I'm not handing them out until I get that done. So we're just going to jump right in. We are ready for 6.6, right? So we're going to talk about numbers in polar form. And it's a matter of vocabulary, not any big news. We're not going to do much new today. It's just how we write our answers. All right, so we've got a complex number. This number is said to be in rectangular or Cartesian form because this is x plus yi. So x is 1 and y is 3. Now I know when we learned about complex numbers before, we called it a plus bi. Again, the variables don't matter. The first one is real, the second one is imaginary. The real component, the imaginary component. So it says plotted in the complex plane. When we plot these, obviously we're going to go over 1 and up 3, and we plot them as vectors. So this is a picture of the vector that represents 1 plus 3i, the imaginary number 1 plus 3i, the complex number 1 plus 3i. The absolute value notation indicates the magnitude or the length of the vector. So that's easy, right? If we came over 1 and up 3, then the magnitude of the vector is going to be what? Square root of 10. Easy, easy, easy. And sometimes that, I call it magnitude, sometimes it's called the modulus of the number. So if you hear the word modulus, it means the length, the absolute value of the number, the magnitude of the number. Now, trigonometric or polar form, those two words mean the same. Polar form, trigonometric form of a complex number is this. That is the polar form of a number. Now, I want you to look at the situation we have right here. For that number, which is in complex form or rectangular Cartesian form, could you find an R and a theta for that picture right there? Can you find R? Hint, you already did. What's R? Root 10. Could you find a theta for that? With your calculator, what would you type in? Second, tangent, 3. Let's see if I'm in degrees or radians. I'm in degrees, so I got 71.57. If you are in radians, you got a different thing, and it doesn't matter. Doesn't matter. Polar form can be degrees or radians. Now I want this to make sense to you. All right, let's just try to understand this and see the connection. If I distributed this right here, if I distributed this, it would say R cosine theta plus R sine theta I. I'm putting the I at the end. What is R cosine theta? X. X is R cosine theta. So this is X, and this is Y. So this is X plus YI, just written with polar coordinates instead of rectangular coordinates. Right? Easy, easy, easy. Convert the following to polar form. Okay. That means make it look like this. This is polar form. Make it look like this. So if we draw this one, it looks like this. Would you agree? What's your R? This is R. What's your R? Square root of 29. Now I need my angle. Be careful with this one. I can second tangent 5/2. This is 68.2. But my argument, my theta, is not 68.2, it is 118.8. Last period of the first day back from spring break, everybody's looking lively here. Are you with me? You okay to up to here? Now, polar form is going to be necessary for us. We've got some stuff we're going to do that requires us to use polar form. It's a whole lot easier to write this than it is to write out all this. Would you agree? Mm-hmm. So there's a shorthand for this. You do not need to write ever again, if you don't want to, for me anyhow, you don't never need to write the longhand form of the number. The shorthand version is this. Now, what do you think CIS stands for? It's the abbreviation for cosine I sine. So if you don't want to write out the number in longhand form, it's perfectly okay to use the CIS notation. These two are exactly the same thing. It's just we're going to be writing a lot of these, and it's easier to write it this way. All right, one more. Minus. All right, see if you can change that one into polar form. We're changing it into polar form. Oh yeah, I kind of need to get your own calculator out. Math is a participation sport. Hank, you got it? Oh no, you don't have your calculator out either. Come on, people! You are so lucky to be here today. Look at all those poor souls stranded on the beach. Colin, you got it?
I think so. 5 CIS 233.13.
What do you think about that, guys? Would you agree?
Yes.
Beautiful, beautiful, beautiful. So everybody feels comfortable changing from rectangular, Cartesian, complex. All three of those words mean the same thing. Rectangular, Cartesian, complex form into polar or trigonometric form. Everybody's good? Okay, now we're going backwards. Now we're going to convert 3 cosine I sine 100 into rectangular, complex, or Cartesian form. Now remember, this is R, and this is theta, right? And we are trying to find X and Y. What do we know about X and Y? What does X equal? R cosine theta. Oh my gosh, beat it in. X equals R cosine theta. Y equals R sine theta. So we just type it in. Isn't it exactly what you do on your airplane problems? When you're trying to find the components of a vector? This is the same thing. It just starts out looking a little different, but it's exactly the same thing. So 3 cosine 100 and 3 sine 100. I got negative 0.52 plus 2.95i. What do you think? Is that right? I want you to think about something as you do this. You're probably never going to miss one of these problems. At least I hope you don't, because you just type it in. But if I plot 100 in standard position, isn't it over here here like this, 100 degrees? Does it make sense that your x part came out negative and your y part came out positive? Yeah, because you're in quadrant 2. 100 degrees is in quadrant 2. All right, 4 CIS pi over 7. Well, obviously, this one's in radians. So I'm going to do everything exactly the same. Except I'm going to have to have my calculator in radians. So make the quick switch over to radians. For cosine pi divided by 7. For sine pi divided by 7. I got 3.60 plus 1.74i. Everybody okay with that? Okay. Convert to polar form without a calculator. So our number is -1 plus root 3i, and we're going to convert to polar form, which means find r and theta. Oh, I can't use my calculator. Let's visualize this. Looks like this, right? Can I do this without my calculator? Yeah, because I know this angle is 60. If I'm in degrees, if I'm in radians, it would be pi over 3. I know if I do the Pythagorean theorem, or just know that if that's a 1, that root 3, this got to be 2. This is going to be 2 CIS 120. Remember, your argument, your theta, always has to be in standard position. No calculator. Convert to complex form. What's complex form again? What does that look like? Complex form is x plus yi. So I need to find x and y. And how do I do that? X equals r cosine theta, and y equals r sine theta. Now this is no calculator. Okay, I think I can do it. What's 7 pi over 6 degree-wise? 210, which means the reference angle is 30, which means this is 1, 2, root 3, and both of these are negative? Everybody okay with that? Okay, we can never forget that. That's going to follow us for our whole lives. Okay, so 5 times the cosine, negative root 3 over 2. And 5 times the sine, negative 1/2. Now be careful. Last time we had class, we wrote our answer like this. These are called the polar coordinates. This is an ordered pair. We're not doing coordinates, we're doing, or not polar coordinates, it's called rectangular coordinates. This is an ordered pair. We're doing rectangular form. So we're going to use the same two numbers, but we're going to write it that way. If your problem starts with an I in it, make sure that it ends up with an I in it, guys. You're going from from polar form to complex form. Gotta have an I.
Why are you subtracting the 5?
It's plus minus, it's plus a negative, right? They're both negative numbers. It would be a plus normally. All right, everybody keeping up so far? Good. Hang on to your hats. This is going to be interesting. We are now going to multiply a couple of numbers in polar form. All right, so this is so exciting. Now, I'm going to go ahead and write out the long form because I want you to remember what that CIS stands for. We're going to multiply these two numbers together. Now, do you have any thoughts on how we can do that? What, Mallory? Birthday girl?
I was just saying, like, could you make it into the CIS?
Well, you can, but that's not going to change the way I have to do it. These are two binomials. How do I multiply binomials? Distribute. I call it FOILing, but it's technically it's distributing. You're right. So 4 times 5. I'll go ahead and take care of that. Now I'll have cosine 32, cosine 20. I'm doing first times first. Plus cosine 32, I sine 20. That's all multiplied together. Plus I sine 32, cosine 20. Plus I sine 32, I sine 20. Big giant FOIL. Aiden?
At the end of the 2 i's, can you convert that into I squared, which would be -1?
Exactly. So, Aiden, these two terms have an I in them. This one doesn't anymore because we're going to make it a -1. So I'm going to go ahead and put the first and the last together. I mean, obviously I can't combine them, but I'm going to write them next to each other. And then these two in the middle, I'm going to go ahead and pull out the I. So I have cosine 32 sine 20 plus sine 32 cosine 20. So with Aiden's excellent suggestion, took these two i's, times them together, got -1. So these two terms kind of go together because they don't have an I in them anymore. And then these middle two, I took the I out and then grouped them together. That colored sheet. You have seen these before.
Yeah.
Joseph?
Isn't that, is that cosine minus cosine x minus y?
Almost. With cosine, the sign's opposite. So this is actually cosine x plus y, or u plus v, or whatever. So we got our 20 out in front, and then this, all this right here, is the cosine of 52, sorry about that, 52. Wait a minute, I changed numbers. That should be a 20, shouldn't it? Yeah, 52. Everybody see that right here? Cosine, cosine, minus, sine, sine. And then what's this? It's written kind of backwards, but remember, it's commutative and associative and whatever. So what's that? The sine of 52? Oh my gosh. I want you to just stop a second. Look at what we started with. We started with 4 CIS 32 times 5 CIS 20. That's what we started with. And we did all this junk. And what did we end with? 20 CIS 52? Next time I do this problem, I'm not doing all that. Because basically, to multiply these two numbers together, we multiplied the R values, and then we added the theta values. When you multiply numbers in polar form, you multiply the R's and you add the thetas. So I'll say that one more time. It'll become important here soon. It's important, period. It's going to become even more important soon. When you multiply numbers in polar form, you multiply the R's, you add the thetas, period. It's that easy. Now, let's use the same two numbers, but let's divide them. What do you think happens when I divide two numbers in complex form? Now, or in polar form. I could go through and do a similar process. It will be even bigger because I'll need conjugates and all that. Or I'm just going to stop and think about this for a second. When I multiply numbers in polar form, I multiply the R's and add the thetas. What do you think happens when I divide? I divide the R's and subtract the thetas. So this problem is just going to be 4/5 CIS 12. Done. That's it. That's all there is to it. When you divide numbers in polar form, you divide their R's and you subtract their angles. So, okay, you guys still look dull. You gotta admit, that is pretty cool. All right, 7a. Now we are multiplying 4 CIS 200 times 8 CIS 300. We're going to multiply them. So what does our rule say? When we multiply numbers in polar form, we're going to multiply the R's, and we're going to add the angles. Everybody okay so far? Now, I say so far because polar form has rules. When you write a number in CIS, polar form, R must be positive, and theta must be between 0 and 360, or 0 and 2 pi, depending on radians or degrees. So 500 is what I get when I add, but it's too big. So I'm going to have to shrink that down and find a coterminal angle for 300, or for 500. What would it be? 140. Yeah, and there's the answer to the question. I'm calling these Z1, or Z sub 1 and Z sub 2 because your book does. It's just a way of naming them. We could call 1A and 1B if you wanted. It really doesn't matter. All right. Z sub 1 over Z sub 2, same numbers. What's going to happen when I divide these two numbers? So I'm going to have 4 CIS 200 over 8 CIS 300. What do I get?
0.5 CIS 260.
Well, it's going to be 1/2 or 0.5 CIS negative 100. That's going to be step 1. But in polar form, the argument theta must be between 0 and 360. So Seth says, okay, can't use negative 100. I'm going to use 260 instead. Is it okay? Z with a bar over it means the conjugate. This is the notation for the conjugate. Remember, these are complex numbers. They're going to have conjugates. let's review what that means for a second. If I have a number like 4 plus 3i, what's the conjugate of 4 plus 3i? 4 minus 3i. Now, you may have never thought about this before, but let's look at those graphically. 4 plus 3i would look like this, right? Over 4, up 3. 4 minus 3i would look like this. Whoops. Now, what do those two numbers have in common in terms of their radius and their argument, their r and their theta? What can you tell me about the r values? They're the same, right? So the conjugate of, what's my number?
4 CIS 200.
4 CIS 200. Oh, that's the original. The conjugate is going to have 4 as its radius. Now, here's the theta of the original number. How does that compare to this angle right here? Same, only this one is negative. Would you agree? So the conjugate of this number is 4 CIS negative 200. And what about negative 200? Can't do it. So the conjugate's going to be 4 CIS 160. There it is. The conjugate of a number in polar form has the same r, but a negative theta. All right, find the conjugate of z sub 2. The conjugate of z sub 2. What's step 1? 8 CIS negative 300. And when I clean that up, it's 8 CIS 60. That's exactly right. Everybody still with me? Okay. What a great lesson to come back to. This is such interesting stuff. Okay. Now it looks like we're going to start raising these to powers. We want to take this number, 3 CIS 10, and we want to square it. Think about that for a second. Think about it. What does squaring mean? Timesing by itself. And how do we multiply numbers in polar form? We multiply the r's and add the angles. So does it make sense to you that this would be 9 CIS 20? Does that make sense? All right, the next one says, all right, let's cube something. So 5 CIS 200, we're going to cube it. Now what does cubing mean? Timesing by itself 3 times. Okay, so that means we're going to be multiplying this number 3 times. Any guess as to what it's going to be? 125 CIS 600 would be the beginning. Now I need that to make sense to everybody. Are you getting it? Because if you are, you're getting one of the most famous theorems in mathematics. It's called de Moivre's theorem. And de Moivre's theorem says that when you raise a number in polar form to a power, basically all you do is take the radius to that power and then multiply the angle times the power. You just discovered that on your own. Now, we do need to clean this up. This happens a lot. Obviously, 600 is too big, so we're going to shrink it down to 240. Perfect. And that's the answer to the question. Now, I want you to think about this for a second, kids. If these numbers had been in, let's say this guy right here, had been in rectangular form, it had been, you know, some x plus yi, and I was going to cube it, what would I have to do in rectangular form? Foil and foil again? Look how handy it is to do it in polar form, right? It's so much faster in polar form. All right, one more of these, and then we're gonna branch out a little bit. We're gonna raise this guy to the 5th power, and we are gonna answer in exact complex form. Now notice the last couple that we've done, we have answered in polar form. De Moivre works in polar form. So it's okay, I can go ahead and do this. What will this be if I raise this to the 5th power? 32 CIS 150. Now this is the polar form, or the trigonometric form. I am to answer in exact rectangular form, which means x and y. So x equals 32 cosine 150, and y equals 32 sine 150. Now, exact means no calculator. So 150, luckily for us, 150 has a reference angle of, who said 60?
30.
Yes, it's 30. 150 has a reference angle of 30. So 32 times the cosine of 150, which is negative root 3 over 2. And 32 times the sine of 150, which is 1/2. So what is my exact rectangular form of this answer?
Negative 16 root 3 plus 69.
Yes, indeed, that's exactly right. Negative 16 root 3 plus 69. All right. I'm going to branch off here. I'm sorry. I don't know if you have room on there. Get out a separate sheet of paper, but I left something out here that I need to put in. Let's suppose that for some reason you need to raise this number to the 10th power. Now in chapter 9, we are going to talk about a shorthand to help us a little bit with the foiling, but no matter how, if you try to do this problem, it's going to be big, and it's going to take a long time. But not if we do it with de Moivre, because de Moivre allows us to raise complex numbers to powers in the snap of a finger. But if you're going to do de Moivre, your number has to be in polar form. So the first thing we're going to do here is change this into polar form. You don't need a calculator. Tell me about R. It's going to be 2 root 2, or I might leave it as the square root of 8. For purposes you'll see in a minute if you don't already have it figured out. And what's this angle right here? 45. So in polar form, isn't this number root 8 CIS 315? Does that make sense? Clayton, you with me? Now I gotta raise that guy to the 10th power. Well, this is not hard. It's big. So I need 8 to the 5th, basically. 32768. 3150. All good? Actually, it's not all good. There's nothing wrong with 32768, but this guy is way too big. So what am I going to do there with that 3150? I can divide by 3150. I can divide by 360. And that tells me it goes around 8 times with 3/4 of a revolution left. So this is really what angle? If it's 3/4 of a revolution extra, 0.75, how big is this angle? 270. Now, if that was at all confusing, you could also take 3150 minus 360 minus 360 minus 360 and just keep subtracting 360s until you get it down as little as it can go. The general rule of thumb is, if the number was given in the beginning in rectangular form, you got to answer in rectangular form. So now we're going to change this back into rectangular form. So x is 32768 cosine 270, and y is 32768 sine 270. Tell me about the cosine and sine of 270. Cosine 0, and the sine is -1. So basically, don't I end up with 0 minus 32768 I? Because the sine is -1. Kids, this always just amazes me. If I FOILed that out 10 times, it's all going to cancel out except that. That's all that's going to be left. I can see that you are impressed by that also. All right, if that didn't impress you, this will. Now we are going to find the square root of a complex number. Wait a minute, Mrs. Ford. You mean we're going to find the square root of I? Yes, we are. We are going to find the square root of this number. And it has an I in it. What's another way of thinking about square root? Exponent 1/2. So aren't I just raising this thing to the 1/2 power? Shoot, de Moivre will do that. De Moivre's theorem says, take the radius to the power. What's 16 to the 1/2? 4. And take the angle times the power. We love de Moivre. It makes life so easy. But there is one thing we're forgetting. If I said to you, take the square root of 9, what would you say? 3 or -3, right? When we take the square root, don't we get 2 answers? Every time you take the square root, you get 2 answers. So even if you go in polar form, you're going to get 2 answers. Now here's something you may not be as aware of. When you take the cube root of a number, you get 3 answers. The fourth root has 4 answers, the fifth root has 5 answers, and so on. So whatever root you are taking, that's how many answers you're going to get. Now you're thinking, Mrs. Ford, wait, the cube root of 8 is 2. Yes, that is the real number, cube root of 2. But there are 2 imaginary numbers that are also the cube root of 2. There are always 3 cube roots, 4 fourth roots, 8 eighth roots, and so on. So this problem has another answer. What will it be? Well, it's very simple. Roots, if you graph them, are like spokes of a wheel. They are evenly spaced around the circle. So if there are only 2 answers, think of a wheel, 2 vectors that are evenly spaced, how many degrees apart are they? If there's only 2 of them, 180 degrees apart. So if the first one is 60, the second one will be 240. There are the square roots of this number. If we were doing a cube root problem and there were 3 roots, they're like spokes of let's get that out of there. They're like spokes of a wheel. If there's 3 of them, how far apart would they be if there were 3 of them? 120. If there were 4 of them, they'd be 90 apart, and so on. Easy. Find the 4th roots in polar form. Oh wait, stop. Here are my 2 answers, okay? But the directions say I must answer in complex form. So what does that mean? X plus yi. So for the first number, x equals 4 cosine 60, and y equals 4 sine 60. And for the second one, x equals 4 cosine 240, and y equals 4 sine 240. Mrs. Ford, this is so tedious. I know, but try taking the square root without doing this. That would be tedious. So just suck it up, enjoy it. Oh, 60 degrees. Cosine is 1/2. Sine is √3/2. So my first number, my first answer, my first square root is 2 plus 2i√3, or 2√3i. Now the good news is, the second one's going to be basically the same, we just have some negatives in there. So 4 times -1/2. So our second square root is -2 minus 2i√3, or 2√3i. So here are the actual answers to the problem, because I had to do it in polar form, or rectangular form. Yeah, now what?
If you do the first one, do you have to do the work for the second one, or can you just add negatives?
Okay, you gotta be careful. If the rotation is 180 degrees, then yes, all you have to do is change the signs. But the next problem we do is gonna be a cube root, and then that isn't gonna work.
Right.
Okay, so yes, as long as you are cognizant, or I guess it's a 4th root, as long as you're cognizant of that, you're okay. Okay, peeps, how are we? Ready for the next one? Alrighty, we want to find the fourth roots. I did two things there. I changed my pi over 3 into 60. Is that okay with everybody? Actually, I better be careful. I think I better leave that as pi over 3. I'm going to answer in radians. It's going to be easier to study. And I said my fourth root is a 1/4 power. All right, so here we go. What does the Moivre say? Going to be the 4 through to 5, 5 to the 1/4, radius to power. So 5 to the 1/4, or the 4 through to 5. CIS, pi over 12. Radius time, angle times power. How many answers does this problem have? 4. Spokes of a wheel, 4, evenly spaced. How far apart are they? 90 or pi over 2. So my 4 answers are going to be pi over 2 apart, or 6/12, right? So I'm going to add 6/12, and I get 7/12. And another 6, I get 13/12. And another 6, I get 19/12. Now, what would happen, do you think, if I was having so much fun adding 6/12, then I did it again? I lost count, and I did it again and added another 6/12. I'd get 25/12. It's the same as the original. There's your check, folks. If you go 1 extra, it needs to reduce back to the original, because you go all the way around the circle and now you're starting to repeat. I actually lied to you a few minutes ago. I said every number has 4 fourth roots. Actually, every number has infinitely many fourth roots, but 4 distinct fourth roots. Because if you keep going, these are all just going to end up getting plotted in the same place. They're going to look different, but they're going to end up in the same spot. Because you could keep adding forever and ever and ever. Thank goodness it says polar form, so we're done. Here are my 4 answers right here. Awesome. Find the cube roots of -1. When I have a plain number, I like to think of it as -1 plus 0i. That gives me an x and a y both to work with. And I want to find the cube roots. What do you think? Anytime I'm cube rooting, folks, I'm going to use the Moivre, because that's the only way I'm going to get all 3 of them. I can cube root -1 and get -1, but I don't get the other ones. So I'm going to do the Moivre. And if I'm going to do the Moivre, then I got to have my number in polar form, right? So what I've got is right here. This is the number that I have. -1 plus 0i. The radius is 1, and the angle is 180 or pi. I'm going to answer in complex form, so I think I'll just leave it as 180. And that is what I want to raise to the 1/3 power. This is not an answer. This number is the problem. It's what I'm going to raise to the 1/3. Okay? So Demoivre says 1 to the 1/3, which is just 1, and 180 times the third, which is 60. So my first number is right there. But there have to be 2 more. What am I adding? 120. I'm going to add 120. Why am I adding 120? Because there's 3 of them in a revolution, evenly spaced. So adding 120 gives me 180, and adding 120 gives me 300. And just for fun, if I add another one, wouldn't I get 420? Which doubles back to 60. Here are your answers in polar form. The directions say I want them in complex. That means X and Y. So here we go, yet again. 60 and 180 and 300. Now the good news is, since my radius is 1, isn't X just going to be the cosine and Y is just going to be the sine? So cosine is going to be 1/2 plus √3 over 2i. Am I going too fast? is on the circle. So cosine is -1, sine is 0. Cosine's 1/2. These are the cube roots of -1. This one makes sense to you because you already knew going in that the a cube root of -1 is -1, right? So that one makes perfectly good sense. These are the odd ones that you can only find using Demoivre. All right, I've blown your minds with one more problem, guys. One more. Hang on. Let's do it. We're going to find the 5th roots of 32. When you were a little child, like yesterday, and we said, what are the 5th roots of 32? You would say 2. But there's 4 more. We're going to find them. Here we go. Jake Sarar, are you paying attention here?
Yes.
You just look like you're zoned out. And I need you to be really focused. Here we go. Let's see how far you can get. You're going to find the 5th roots of this number. So 1/5 power, right? 1/5 power. We're going to find the 5th roots. We got to do Demoivre, which means our number has to be changed into polar form, right? Oh shoot, these are going to be in complex form, oh Lord. All right, so we're going to change this number into polar form. What's it look like in polar form? 32, 0, isn't it just right here? So your radius is 32 and your angle is 0. So 32 CIS 0 is the number. Okay, so here we go, Demoivre. 32 to the 1/5 is 2. CIS 0. 1/5 times 0. But there are 4 more answers. Five altogether. They'll be evenly spaced, so they'll be how far apart? 72. Since the first one's at 0, the next one's at 72. And 144, 216, check my work, 288. Actually, I can check my work because if I go an extra 288 and 72, if I go an extra, I get 360, and 360 is the same as 0. So I'm okay. Except it says complex form. What does that mean? Gotta find X and Y. Got my trusty calculator. Actually, this one I can do without a calculator if you want, but you're gonna need it for the rest. So remember, X is our cosine, and Y is our sine. So 2 cosine 0 is 2, and 2 sine 0 is 0. That's the one you knew you were gonna get. Because when you take the fifth root of 32, you get 2. That's one of your answers. The rest of these, I don't know. 2 cosine 72. Oops, make sure you're in degrees. I was in radians, which is bad for this problem. So 2 cosine 72 and 2 sine 72. Remember, I is always hooked to Y. What do you think? That's what you got? You're thinking, oh my gosh, this is the best day ever. And now we're gonna have homework due